Hi there, Mr. Sutton here, bringing you the IM3 Chapter 2 Quiz 1 review solutions on basic factoring. To simplify on this problem, we basically have to distribute or multiply this 3x squared by every term that's being added or subtracted inside this parentheses. So we start with 3x squared times 8x squared. That's going to be, 3 times 8 is 24. X squared times x squared. We add the exponents using our exponent rules. So that's x to the 2 plus 2, or x to the 4th. So then 24x to the 4th. Next, we have 3x squared times negative 8x. That's going to be negative 24 x to the 2 plus 1, so x cubed. And finally, 3x squared times 6 gives us 18x squared. In order to simplify this problem, we have to multiply these parentheses together. Since there's more than one term in each parentheses, we have to multiply the first term in the first parentheses by the whole second parentheses, and multiply the negative 4 also by the second parentheses. So basically, multiplying everything in the first parentheses by everything in the second parentheses. We'll have 4 multiplications when all is said and done. So we have 6p times p, that's 6p squared. And then we've got 6p times negative 5, that's going to be negative 30p. So again, we're just distributing 6p to the second parentheses. Now we'll do the same with negative 4. Negative 4 times p is negative 4p. And then we have negative 4 times negative 5 is positive 20. Now another way to think about this, a little shortcut you can use with a 2 by 2 is a FOIL is the acronym for it. That would be firsts, outers, and then the inners, and then the last. It's just telling you what order to do the multiplications in. So in any case, you have these 4 multiplications. You can add like terms in the middle. We have negative 30p minus 4p, that's negative 34p in the middle. We still have the 6p squared and the 20 as well, and since there's no more like terms to be combined, this problem is done. For this problem, we're trying to multiply this binomial by this trinomial. Basic idea here is we have to multiply everything in the first parentheses by everything in the second parentheses. So I'm just going to write as an extra little step to let you know what I'm doing. We have 6r times the whole second parentheses minus 4 times the whole second parentheses. So basically splitting up the multiplication. And now we just distribute for each of these. So 6r times 2r squared, that's going to be 12r to the third. We're adding the exponents, 1 plus 2. Next we have 6r times negative 5r, that's negative 30r squared. 6r times negative 7, that's negative 42r. Now we distribute the negative 4. Negative 4 times 2r squared, that's minus 8r squared. Negative 4 times negative 5, that's positive 20r. And finally, we have negative 4 times negative 7 for 28. Combining like terms, we see here that this 12r cubed is the only cubic term, so that just comes down and doesn't change at all. Negative 30r squared and negative 8r squared, those are like terms. Same variable and exponent, so we add the coefficients and keep the variable in the exponent. That'll be negative 38r squared. Then we have negative 42r and 20r. We can combine that to get negative 22r. And finally, this plus 28, that's the only constant. So there's no like terms for that one. That just comes on down. On this problem, we're trying to simplify by dividing this whole polynomial by this monomial. Since these are being added together, you can think of this as just distributing the division to each of these terms. So we can have 30v cubed, 6v squared, and 2v, each getting their own denominator of 6v cubed. And now we just have to reduce and simplify all these fractions. So 30 over 6 is going to be 5. The v cubeds cancel completely, so that's just 5 that we can simplify that first term to. And for the next one, the 6's cancel. V squared over v is going to give us 1 over v. And then we have 2 and a 6 reduces to 1 over 3. V over v cubed, that cancels out one of the v's downstairs, leaving us with a v squared. So we have 1 over 3v squared that we're adding in there. For this problem, we're trying to factor this expression. Now we should always start by seeing if there are any common factors that we can take out. 96 and 72, what are those both divisible by? Well, let's see here. They're both divisible by 2 definitely, and also 3, so that means they're divisible by 6. And we could probably go a little bit further than that. They are both divisible actually by 12. I think 12 is the biggest number we can take out of both of those. 96 divided by 12, that's going to be 8. 72 divided by 12 would be 6. Actually, I think we could do even better. 24. 24 is the biggest number. Okay, so take out things in stages if you need to, but 24 is the biggest number we can take out of those constants, those coefficients. And these both have x's, so we can factor out an x as well, x to the second power, since that's the lowest exponent out of the bunch. So when all is said and done, we can factor out a 24x squared, and 96 divided by 24 now, we're just going to basically divide both of these by 24x squared and put the leftovers in a parentheses. So 96 over 24, that's 4. X to the fourth divided by x squared is x squared. So that's 4x squared for that first term. And now 72 divided by 24 is actually 3. X squareds cancel completely, so this is just minus 3. And there's nothing else we can do there, so this one is done. To factor this problem, let's first check to see if there's any common factors I can take out of all 4 terms. And let's see here. It looks like there is not. I mean, 3 and 4 alone kind of are deal breakers. Those don't have any common factors other than 1. Nor do these terms all have the same variables. So that means that we move on to other techniques. Since there are 4 terms, we know that grouping is at least a possibility. To check to make sure it's a possibility before we even start writing stuff down, we can look at the ratios of the coefficients. So the first 2 coefficients, 12 and negative 3, that's a ratio of 4 to 1. And the next 2 coefficients, 16 to 4, that's also a 4 to 1 ratio. And we've got negatives in both. So grouping should work on this one since we have the same ratio. Let's take a common factor out of the first 2 and the last 2 terms to get this started. For the first 2 terms, 12 and 3, both divisible by 3. We can also take an x out of both of those terms since they both have x's. So 3x then is coming out of those first 2 terms. 12xy divided by 3x leaves us with 4y for that first term in parentheses. And then this negative 3x is just going to become a 1 if I take a 3x out of it, so minus 1. For the next 2 terms, all we can take out of these is a negative 4. So if I take that out, this first term becomes a positive 4y. And this positive 4 now becomes a negative 1 if I divide it by negative 4. Since I've got the same thing in both of these parentheses, that means I can take this 4y minus 1 out as one big common factor. And then I can put a parentheses with the leftovers after I take that out. So that's just going to be the 3x and the minus 4 that are left over when you divide both of these terms by 4y minus 1. So 3x minus 4 in that second parentheses. On this problem, since I'm trying to factor a trinomial, and it has an a value, which is to say the coefficient of the squared term is 1, that means that I can just look for numbers that multiply to give me this constant and add up to this middle coefficient. So specifically on this problem, I want factors of negative 70 that add up to 3. And since I know that negative 70 is a negative, that means I have to have had opposite signs for my factors to multiply and get a negative. So I'm looking for 2 numbers that have opposite signs. So factors of 70, we've got 1 and 70, but there's no way to add that up and get a 3 out of that, even if one of them's negative. We have 2 and 35. At best, we could get 33 out of that, so still not what we're looking for. What else multiplies to give us 70? Well, 5 goes into 70 14 times. Still can't get a 3 out of that. Then there's the more obvious one, 7 times 10. We can get a 3 out of those if we have a negative 7 and a positive 10. So that's what we're actually going to end up putting in parentheses with the r's here. We're going to have an r minus 7 and an r plus 10. And if you wanted to check your answer, you could FOIL this back out, multiply this back out, and combine like terms, and you would see that we do indeed end up with what we started. On this problem, trying to factor this trinomial, I'm going to need factors of 42 on this one that add up to 13. And since we multiply to get a positive, that means the signs are both the same for our factors. And since we add up to get a positive, they're both positive. So factors of 42, we've got 1 and 42, does not add up to 13. 2 and 21 still doesn't add up to 13. We've got 3 and 16, subtracts but does not add up to 13. And then what else do we have? There's a 4 doesn't go into this. How about 6? Oh yeah, 6 and 7, that's a good one. 6 and 7, those add up to 13. So we can rewrite this as the product of parentheses x plus 6, x plus 7.